Swamped by summer? Feeling overwhelmed by the relentless heat? It's not just the heat. There's more to it than just the blazing sun. Ever notice how a 90-degree day can feel drastically different depending on where you are? It's not your imagination. Take a stroll on the Santa Monica Pier, and you might find yourself reaching for a light jacket, thanks to the cool ocean breeze. But venture into the humid heart of a Florida summer, and that same temperature can feel like an unbearable sauna, making you sweat buckets. What gives? The answer lies in a single word: humidity. It's the hidden factor that changes everything. We often talk about temperature as the sole indicator of how hot or cold it is outside, but that's only part of the story. Humidity, the amount of moisture in the air, plays a huge role in how we experience temperature. It can make the air feel much hotter or cooler. In fact, it can make or break our comfort levels, turning a pleasant summer day into a sweltering ordeal. The difference is palpable. So, let's delve into the science behind humidity and uncover why it feels so much hotter when the air is thick with moisture.
What is humidity anyway? More than just a feeling. Humidity is essentially the amount of water vapor present in the air. Think of the air like a sponge. It can only hold a certain amount of water. The more water vapor in the air, the higher the humidity. We feel this moisture as that sticky, heavy feeling in the air, especially on hot days. But how do we measure this invisible force? We use something called a hygrometer. This nifty tool tells us the relative humidity, which is the percentage of moisture in the air compared to the maximum amount it can hold at that temperature.
Let's talk now about relative humidity and dew point. Understanding these two concepts is crucial for anyone interested in weather patterns and atmospheric conditions. Relative humidity is all about percentages. It tells us how much moisture is in the air compared to the maximum amount it can hold at a given temperature. Let's say it's a warm day and the relative humidity is 90%. This high percentage indicates that the air is almost fully saturated with water vapor. This means the air is holding 90% of the maximum amount of water vapor it can at that temperature. Essentially, the air is nearly at its capacity for moisture. It's pretty close to being saturated. When the air is this humid, it can lead to fog, mist, and even discomfort for people. But there's another key player in this atmospheric dance: dew point. The dew point is a critical measure that helps us understand how much moisture the air can hold. The dew point is the temperature at which the air becomes fully saturated and the water vapor condenses into liquid water. Remember that sponge analogy? It's a simple yet effective way to grasp this concept. When the air reaches its dew point, it's like the sponge can't hold any more water and it starts dripping. This is why we see dew forming on surfaces in the morning. A high dew point means there's a lot of moisture in the air, and it's going to feel muggy and uncomfortable. This is why high humidity days can feel so oppressive. Think of it this way: the higher the dew point, the closer you are to feeling like you're swimming in the air. It's a tangible way to understand the impact of moisture on our daily lives.
Our bodies are pretty amazing machines equipped with a built-in cooling system, sweat. This natural mechanism is essential for regulating our body temperature. When we get hot, our bodies release sweat onto our skin. This sweat is primarily composed of water, with some salts and other substances. As the sweat evaporates, it takes some of the heat energy with it, cooling us down. This process is known as evaporative cooling and is crucial for maintaining our body's optimal temperature. It's a brilliant system, until humidity gets in the way. High humidity levels can significantly disrupt this cooling process. High humidity means the air is already saturated with moisture. This saturation level makes it difficult for additional moisture, like our sweat, to evaporate. Like a soggy sponge, it can't absorb much more water vapor, even the sweat evaporating from our skin. This results in sweat lingering on our skin, making us feel hotter. This makes it harder for our sweat to evaporate and cool us down effectively. The body struggles to maintain its temperature, leading to discomfort and overheating. So we stay hot and sticky, even if we're drenched in sweat. The sweat-soaked clothes add to the discomfort, making us feel even more miserable. This is why a dry heat, even at high temperatures, can feel more bearable than a humid heat. The lack of moisture in the air allows sweat to evaporate more efficiently. In dry climates, sweat evaporates quickly, providing efficient cooling. This rapid evaporation helps to keep our body temperature in check. But in humid climates, that cooling effect is hampered, making us feel much hotter than the actual temperature would suggest. The oppressive humidity can make even moderate temperatures feel unbearable.
Humidity is an important factor in weather and how we experience it. By understanding this science, we can stay cool, comfortable, and enjoy all types of weather.